Hello there, smart learner. Oh my goodness is my name. You may address me as Mr. OMG. I enjoy math questions until I have to eat math questions 5 times a week. I eat primary questions for breakfast, secondary questions for lunch, JC questions for snack, university questions for dinners, math Olympiad questions for suppers. I'd like to share with you what I eat in a week. Remember to like, subscribe, and comment. If you're lucky, your comment will appear in one of my videos. Olympiad questions. Given that fx is function where this, find f minus 2017. So this is our objective, is to find f minus 2017. Yeah. So from here, let me break it down like this. Yeah, this is f1, f0, f2, f3, f4, f5, f minus 1, f minus 2, and so on. Okay, yeah. We know that f minus 2 is 5. So this is 5. So I will write it like this. Okay, yeah. And look at this. F minus x equals to minus fx. So basically, f2 will equals to minus 5 from here. Do you understand? What I mean here, like f minus 2 equals to minus f2, right? Yeah. So this will give us 5 equals to minus f2. f2 is minus 5, so we get it. Yeah. So again, and fx equals to fx plus 3, so we can say that f5 equals to f2. Yeah. So if we substitute x equals to f2 will equals to f5. Yeah. And that give us f2 equals to f5 minus 5, and f5 equals to f8, and so on. Yeah. F2 equals to f minus 1. Yeah, because if we substitute x equals to minus 1, f minus 1 equals to f2. Yeah, and so on. Yeah. And because of that, because we know f minus 2, yeah, plus 3. Yeah, f1 is 5, f4 is 5, f minus 1 5 is 5. Okay, yeah. So basically this, yeah, if we it repeating every 3 digit. Okay, yeah. So if we divide it by 3, yeah, this, yeah, if the remainder is 1, yeah, 3 divided by 1, this remainder 1. Yeah, yeah. And when divided by 3 and the remainder is 2 is this. Yeah, this is, and this is where remainder is 3. Yeah, when the remainder is 3, this one remainder 1, remainder is 2. Yeah. So for this case, yeah, 2017 divided by 3, what is the remainder? So we divided this. Yeah. So the remainder is 1. The remainder 1, so is the answer is either 5 or minus 5. However, it's negative here, so the answer is this, negative. So negative 5, and that's the answer. Olympiad questions. This question is about recurring decimal, is to find the 2017 digit after decimal points. Yeah, so this objective. Look at this. 41 is that divided by 9 divided by 271. So we can say that 1 over 41 is equals to 2439 divided by this. Yeah, will if you see this decimal, it's a recurring decimal, which is this, and it's repeating every 5 digits. Can you see that? Yeah, whereas 02439, yeah, when the digit divided by 5, remainder 1 it falls to 0, and so on. In remainder 0 falls to 9. Yeah, look at it. 2017, when we divided by 5, the remainder is 2. So we can see that the remainder 2, the digit will be 2, and that's the answer. Olympiad questions. So this simplify the following of these questions. Yeah. So objective here is to find the value. Okay. Okay. Please remember that 1 plus 2 is 2 times 3 over 2, and this is 3 times 4 divided by 2. Yeah. And until 1 plus 2 plus this is 9 times 10 divided by 2. This is arithmetic sequence. Okay. Yeah. Sum of arithmetic. And from here we can switch them all into this, like this is 2 over that. Yeah, and this equals to that, yeah, and this the last one equals to that, yeah, and the 1 over n times n plus 1, this equals to 1 over n minus n plus 1. Okay, so basically if we factor out all 2, yeah, this we can switch into 1 minus half, half minus 1/3, and so on until this, yeah. So we can cross out the middle, this all cross out until 1 over 9. So what we get here, only 2 times 1 minus 1 over 10. This for easy for us to count, yeah, and this equals to 9 over 5. 9 over 5 is the answer, and that's the answer. Olympiad questions using logarithm. Given that this, and the objective is to find the value of 10 to the power of 2a minus b plus 1, to find the value. So this is 10 to the power of 2a, this is a, yeah, minus b, this is b, and this is 1. 1 we can switch into log 10, okay, yeah. So using the logarithm formula, yeah, 2 we move to the exponent, log 10 9 minus log 10 2. So we can combine this because they have the same base, okay, yeah. So log 10 45. Okay, you must wondering why the answer is 45, because there is a formula in logarithm law which is a log ab, which is equals to b. So 45, and that's the answer. Olympiad questions. This is an arithmetic progressions where the 8 terms is 2018. So this is arithmetic progression. So we use the formula un equals to a plus n minus 1d. So we know that 2018 equals to a plus 7d. And the objective here is to find smallest possible of the first term. Okay, we have 4 choices, which is 3, 2, 5, and 1. Yeah. If we substitute, yeah, a into the equations, yeah, we get d equals to 287.85. And this is wrong. Why? Because the difference must be integer. So if we do the same method for everything, every choice here, we find that only 2 is have the difference integer. So the answer is 2, and that's the answer. Olympiad questions. So given that this is a simultaneous equations, and the objective is to find the value of x plus y. Look at this, okay? 32 root x. This means 2 to the power of 5 over x. This using law of indices, yeah? And the other one is 2 to the power of 3y minus 6 over y, okay, yeah? You can take a look at your law of indices to understand this concept, okay? While the other one is 3 to the power of 15y, we don't change anything. While 81 is 3 to the power of 4, which is this, okay, yeah? So we know that by comparing the exponent, x equals to 5y over 3y minus 6, while the other one is this, yeah? So our job is to substitute x here to find the value of x and y here, okay, yeah? So this is the x, yeah, we substitute 15y plus 3x equals to 4xy. Substitute. After we substitute, we make the same denominator. We get this 45y squared minus 90y plus 15y, and this, and we cross out the bottom because they're same, 3y minus 6, and we get the quadratic equation, which is 25y squared minus 75y equals 0, and this gives us y equals 0 or y equals 3, okay, y equals 3. This is rejected, okay, because it cannot be 0, yeah, and y, and the answer also cannot be 0. When y equals 3, we substitute here, yeah, so 5 times 3 over 3 times 3 minus 6, if you count this, you'll get this 5, so that's why x equals to 5, yeah. So we can find the value of x plus y is 8, then, and 8, then that's the answer. Olympiad questions. So what is the remainder when 11 to the power of 20 is divided by 1000? Yeah. So we can use binomial expansion to do these questions, yeah, where this is 10 plus 1 to the power of 20. In binomial expansion, this is 20c0, yeah. Next one 20c1 times 10, 20c2 times 100, 20c2 times 1000. But we can ignore the 1000, why? Because it's divided by 1000. This can be cancelled out, okay? So what's left here is only this 3, which is 20c0, which is 1, 20C1 times 10, 200. 20C2 times 100 is 9,000 mod 1000. Okay, so what's right for us? This doesn't give us remainder, so what this 201 is the remainder, since the objective is remainder and 201, and that's the answer.